Hello, everybody. Welcome. I'm glad to be here. Thanks for the invitation. This is my second time at the Open Data Science community, and this time in London. I want to talk about orchestrating LLMs, AI agents with CrewAI. So the reason why I decided to make some noise about this topic is that I had the chance to work on these LLMs applications for a while, and I found out that there are a lot of interesting frameworks around, maybe too many, and I decided to focus on one. In this case, I will try to start the conversation with what I think is the LLM's approach to software engineering. And we will talk about orchestration and how orchestration is implemented in CrewAI through concepts and topics like agents, tasks, and crews. We will look into this framework, and then we will have a look into the use case. And by the end of the talk, we'll move to the conclusions. So, who am I? I don't want to waste too much time on this. If you want to know more, just reach out. I'm really approachable. You can talk to me about music and skis, whatever you want. In a nutshell, I'm a data scientist. I've been exposed to many domains. I had the chance to work a lot in pricing and so far so on. So feel free to reach out if you want to know more about me. So what is software AI engineering? I really care about this topic because I see that many people are working with prompts, and in my opinion, sometimes we over-engineer prompts engineering. This basically means that we are expecting to do too many things with the prompts, and we're trying to build huge applications based on prompts, but without thinking about software engineering, without thinking about the things that we did learn during the last decades or even more. So we do have important pillars coming from software engineering, and I think we need to apply them to LLMs applications. So what is happening now is that we can refer to LLM software applications whenever we have something that is more than just a prompt, but we need to build a whole shell around it. So in order to reuse maybe what we're doing with the prompt and have extra tools that are not kind of binded to what we're doing, but they can eventually be reused. So I'm not inventing anything here. I'm just talking about pure software engineering applied to LLMs. So we're talking about making everything scalable. On the security side, we want to have features for encryption and compliance. We want to have standardized workflow. So if we move to another framework, we know what to expect because we have some standards. And also one interesting point is pre-built components. So we want to work with something that can be reused and relies on things that not just like, free text written into a prompt, but some real applications that can be reused across our multiple solutions, for instance. So we have a lot of frameworks. I'm not inventing anything here. Of course, once we started working with prompts, we decided we needed some frameworks. Maybe we have too many frameworks. This is just like my top 5 LLM frameworks list, but we have many options. As I said, maybe too many options. And the idea behind frameworks is basically still, we're not inventing anything, is to have something that can make everything reproducible, so we can write applications with components that are scalable and so far so on. One example is I don't want to focus on one specific model, but instead I want to have components that can work also against another model. So this is the main idea. And if I'm using an extra tool, an extra function, this function is not something I'm writing into the prompt, or is not a request that I'm sending to the model, but instead it's a proper function that can be also used across different applications. So yeah, we need some standardization, we need some frameworks. LLM as a software. Why I'm talking about this? Because as a data scientist, my final goal is to provide solutions. And when I talk about solutions, I talk about software. So all the things that I do, apart from some simple analysis, are things that need to be integrated in something bigger. Usually, is never like a standalone solution. So we need this kind of LLM as a software. We need modular setup. So we want to encapsulate the prompts into something that can be flexible. If we want to adjust something, we can easily do it. We're not just working with free text, for instance. We have also the need of something that is dynamic and can be also can be easily evaluated. What I mean is that if we have a bunch of prompts doing something for us, changing something based on a new requirement can be very complicated, especially if the prompts have a lot of logics mixed all together. We will see the concepts of tasks and agents. If we have all these concepts together, changing some prompts of an application can be very challenging. So this is why we're talking about CrewAI, and this is why CrewAI, together with some other frameworks, of course, make a huge difference if using a framework is what you need, of course. First of all, let's dive into orchestration. So why I think that agents orchestration is important? Well, we have a difference between orchestration and automation. When we have to automate something, we just have we're setting up one task to run on its own, and this is a concept that it's really easy to understand. As well as with orchestration, we're trying to automate many tasks as a process or workflow. This is a bit more complicated because if you think about orchestration, it is usually connected to optimization. So when we want to orchestrate something, it means that there is some kind of central unit that is trying to work with some subunits in order to solve most of the times an optimization problem. So in terms of agents orchestration, what happens is that we have role-specific agents. So we have agents designed to achieve specific tasks, and then we can have an adaptive orchestration where the agents are basically following the instructions of some sort of manager, which is also an agent, but is taking care of delegating the tasks to the agents, and also understand if the agents are going in the right direction. So it's all about optimization. Basically, CrewAI provides these concepts out of the box, and the nice thing about that is that if you need orchestration, if you need these concepts, you don't have to implement them, but you can focus on the problem you want to solve. You can focus on the objective, the constraints, and then you let CrewAI work on the implementation of the orchestration, the agents, the tasks, and the crews under the hood. So when is CrewAI needed? Because I had the chance to talk to many people using prompts and LLM frameworks, and they didn't know anything about CrewAI. And it's really important to understand when CrewAI is needed, because if you're already using a framework, maybe you don't need CrewAI unless one of these points is important for you. Multi-agent coordination. This is definitely one of the most important. What does it mean? Well, if you have agents, but you also need to orchestrate how these agents are working together and how these agents are creating outputs for your application, maybe you need this multi-agent coordination. So you need this so-called manager that is working on top of the agents and decide how the agents have to behave. If you need some role customization, so if the agent is not just an agent but is also a manager, so the manager is like delegating tasks to the agents. if you want to have scalable deployment, or if you want to have a simplified development, because you don't want to, in this case, implement the concept of orchestration, but you want to use it out of the box and instead focus on the business side, on the problem you want to solve. Now, let's dive into the concepts that have been implemented in CrewAI. The first is the agent. What do we do? How do we look at this new class? So it's really simple. You can imagine that the agent is like a real agent, like a real person having a role, a goal, and a backstory. And I think this explanation already does the job, because the role is just what the agent does. The goal is what's the final goal of this agent. For instance, summarize a short bio for input, and if needed, do more research. And the backstory is something that gives more kind of color to the agent in order to achieve the task a bit better. You can imagine that if you think about it, we're not talking about what the agent has to do, because this is implemented in a different class, which is the task. This is really interesting because until now, we have seen how the agent is implemented and what the agent, what's the agent final goal, but we didn't talk about the task itself. So what are we doing with this agent? What do we let the agent, how do we feed the agent? What kind of information we give to the agent? So this is done in the task. In the task, we define what the agent does exactly. In this case, the sales agent, the description of the task for the sales agent is find and summarize the latest and most relevant news on AI. This is interesting because if you think about how this can be implemented in a prompt, you will see that the result is a probably quite long and complicated prompt where the task is mixed together with agent information. But this is not really what we want, because what happens if the specific agent, so the one we saw before, has different tasks based on different decisions? How can we do it? How can we create two prompts where two prompts that are sharing something in common in a smart way, of course, not just like writing, okay, you're a salesman, but with some backstory, with some goals. This makes like the prompt quite complicated to implement and also modify in the future if something changes. Now we move to Cruise. Cruise is probably the final class you're gonna use if you write a project with CrewAI, because the Crew puts together all the agents you have, all the tasks that you have, and in the Crew we define which process we want to use. The process is, we will see in the next slide, is probably one of the most important concepts we have in CrewAI, and with the process we define which kind of collaboration we want to have between the agents and eventually the manager, if we have a manager, if we have an agent manager. And we can have different crews, and with the Crew we define the final set of instructions and agents we want to put together in order to solve our problem. Now, before looking into the use case, it's important to understand which kind of process we can use in CrewAI. The most, probably the most famous, the most like recognizable is sequential. With sequential, we just mean that we execute one task after the other. This is it's a cascade approach, and it's really easy to understand probably. But then we have another powerful process, which is hierarchical. Hierarchical is really interesting, and it's what we're going to use in the use case. And it's needed when you have a manager that has to delegate the tasks to the agents. This is important whenever you have the agents working on some optimization problem, and maybe you have to evaluate the output and understand if the agent has to look for another solution or some other information, or maybe the results of the agent is not satisfying because you have a specific constraint. So the manager has to evaluate if whatever we get from the agent is reliable, or I don't know, it makes sense based on the constraints you have. We will see how this process hierarchical can be used, especially in the use case. Now, finally, before diving into the use case, I would like to spend a couple of more words about collaboration. Collaboration is something that and as we saw, the different processes we have in CrewAI, is something you can implement. Nothing is going to stop you if you want to implement these concepts in Python and use them. Of course, the problem here is that this takes a lot of time and a lot of knowledge, because it means that you have to deal with prompt, and then you will have to create some kind of feedback loop where each prompt outputs is evaluated before the next section is kind of fired, or before the next session, the next action takes place. So it's important to understand that the collaboration, basically, it's in CrewAI, it's about sharing information among the agents, having some roles, allocating the resource in order to optimize the tasks. So it's not just about taking a prompt and sending it to an API, but it is basically a mix of things that that are happening under the hood, that basically improving the application, and eventually, if those things have to be implemented, will require more knowledge and probably more time. Now, let's dive into the ski trip use case. This is something I had to deal personally, because I like to ski, but I'm not a professional, and I started skiing just a few years ago, maybe 4. And this is a picture of a friend of mine. You will not believe, but he's actually laying on the snow. He fell in this specific picture, but I'm just making fun of him. Basically, the problem that I had when I started skiing is that, of course, I didn't want to go skiing alone, and I was looking for friends to go ski with me. And the problem I had was that we were all located in different cities or countries. In my specific case, I live in Hamburg, and I have another friend living in Madrid, and another one in Italy. So it was really complicated at the beginning to find the right spot for us. So I was looking for the right place in terms of cost mostly, but the right place for us was also a place that is reachable by the 3 of us, also a place that is kind of that matches our different skill levels, so it has to be affordable, and also we're looking for something where we could easily rent our equipment, because we don't have a car, so we wanted just to reach the place and be able to rent all the equipment we needed. So this is an optimization problem. I cannot just put all this information into a prompt and pretend the prompt to give me the best answer. This is simply because, first of all, if I have to do this manually, it takes a lot of time. Of course, I don't have to explain why. And because of the main iterations you have to do, so you find the right place, and maybe you want to change it because there is no renting shop, or maybe it's too expensive for the person coming from Madrid, and so far so on. So this is quite challenging in terms of iterating over and over. And if you write everything, if you put all this information into a prompt, how can you pretend the prompt to give you the best answer possible? So it's an optimization problem. So what I decided to do is, as I said, work with CrewAI. So because I understood that, first of all, I wanted something scalable, because I was like, okay, these are the constraints I have now, but maybe there would be new constraints or new people joining, or maybe there would be less constraints, because at some point I feel like I'm not a beginner, and I can also take out the constraint where I say, hey, look for places where the resorts are for beginners. So I can take out that constraint. And another reason why I wanted to solve this problem is because I wanted to use LLM for something practical and not just like small issues and weird prompts. So yeah, let's dive into the implementation. First of all, we start with the agents. So we have to define all the agents that we need to make this work. First of all, we need an agent that is in charge of finding the best location. This is the ski destination researcher. The ski destination researcher is in charge of finding the best destination based on the people eventually that are coming, that wants to join this trip. Then we have the accommodation specialist. This is an agent that is in charge of finding something comfortable and eventually close to the ski resorts. And then we have the ski rental advisor. The ski rental advisor, of course, is in charge of finding the renting shop. So these are the things that I need. In reality, there are more agents than the 3 agents you see here, because I also had some other, as I say, this has to be scalable. So at some point I also had more constraints and more requirements. So I do have more agents, but for the sake of this use case, the presentation, I don't want to go through all the agents that I've implemented. But this is quite, they're not really far away from what you see here, I will say. So now that we have the agent, we need a manager. So where is the manager? I'm saying here. It's really important now that we understand what we want to do, because this is not just about let the agents do the job and then get an output from them, but this is also about optimizing what the agents are doing. What I want to do here is not just like looking for a ski trip, for a ski location, but I also want to look for a ski location, for instance, with a renting shop close by. And what if the ski researcher location finds something that doesn't have a ski resort? Well, the manager has to go to this agent somehow and say, hey, this is not what we're looking for. Please find something else, because there is another agent who just said that there is no ski location in that area. There is no renting shop in that area. So we need to do it differently. This is the reason. So I have to orchestrate what the agents are doing, and there will be some sort of feedback process happening under the hood that I don't see, which I hope is optimized as CrewAI says. And this process is the core of what I want to do, because I'm talking about optimizing all this, optimizing my goal based on a set of constraints. So it's really important that you define an agent, which is a manager, with this allow delegation equal to true. This means that this specific agent is a manager and is in charge of delegating operations to each agent. Now, just a few words about this. Can I implement it myself? Can I implement this myself? Of course, but it's complicated. So it's complicated, it takes a lot of time, and it's not scalable. But yes, you can do it. But in my case, I ask myself, why do I want to do this if I have CrewAI available? So that was my main reason. Now, implementing the tasks. This is where we tell the agents exactly what to do. We don't have to go through all the tasks. It will be very boring, but for the destination finder, we just says, okay, you, as a destination finder agent, research as key destination that is accessible by the names of the people, starting from their locations, so far so on. Consider the cost of flights and their preferred skiing levels. Now, in this case, we have, of course, some tools that we define actually in this step. Tools equal to search tools that are basically tools used by the agent to achieve the tasks. Tools is really interesting because it means that you can give the agents the right tool to achieve their tasks, and these tools can be something like the possibility to search the web, navigate the web, the possibility of maybe contacting some booking.com APIs, and so far so on. So the tools can be anything, and it's something that is used by the agent to achieve the goal. It's really interesting because if you think about the possibility to provide a tool, this can also be done in LangChain and all these frameworks. You're basically creating something that is scalable and reusable. If you want, you can use this tool in another framework, the agent can, any kind of agent can actually exploit the tools that you're implementing in this specific use case, for instance. Then we have the manager. The manager is still, we have the task for the manager. This is also quite interesting. That's why I want to highlight the task of the manager here. And it's because in this case, we're basically implementing our constraints. So we're basically saying, okay, this is the manager, and we want the manager to delegate information based on what the manager sees from the agents, and the manager makes sure that everything is affordable, and the overall trip is not expensive. Now we assemble the crew. What does it mean? Assembling the crew together just means that we have to put all these agents and tasks in the same class, and we decide which process we want to use. As we said before, in this case, we go for hierarchical. Hierarchical, it's what we need, and as explained before, it's what you need whenever there is a manager delegating operations, delegating tasks to agents. And that's pretty much it. The final output of this application is something like this. So as you can see, for this specific example, I get Chamonix, which is actually our choice. It was in the end our choice in February. And then you get all the information that you need in the ski trip details txt, this file I'm using as final output, with the links to the hotels, the tickets, and so far so on, and all the detailed information about the trip. Now, it's time to move to the conclusion. First of all, this was definitely a lot of fun. I enjoyed working with CrewAI, and there are many things that I loved about it. First of all, it's a low-code experience. So you can put a lot of logic into the tools that you're using for the agents, but in the end, the whole experience is a very low-code experience. You don't have to implement all these powerful concepts you have, like orchestrating agents and working with crews. This is all implemented, and it works very well. So for me, it was a pleasant experience. It's also community driven, so you find a lot of tools that can be used inside CrewAI, which are basically directly coming from the community, or you can even use tools coming from LangChain. One example is searching the web. You will find a lot of tools that you can use to search the web, and you just have to put the API of whatever engine you want to use, and it will work out of the box. Of course, it's scalable because you can take the agents, you can take the tasks, you can reuse all this information, all these classes, and it's easy to integrate. You're working with Python, and for me, it was a big kind of relief when I had the application and I was able to integrate it with, I don't know, my Streamlit application, my Streamlit UI. So yeah, it was a pleasant experience. But at the same time, there are some things that I don't like, not just about CrewAI, but in general about using frameworks. First of all, I had some problems with all these updates we get from CrewAI. So it was complicated to work with I don't know, the updates for this specific class that is changing the signature of this function and so far so on. So I understand that the needs are changing, everything is evolving, but of course sometimes working with this framework it can be annoying because of these reasons. Another problem is that you have to accept whatever you find in the framework. So you have to learn something new, and this means that you're not just like working with prompts, but you also have to work the framework way. So you have to understand how CrewAI does whatever they do, and then adapt to that kind of interface and so far so on. And of course, it's not always customizable. Sometimes you just get things out of the box, which is great for some problems. But if you want to go a bit deeper, you cannot really change everything. So you have this hidden complexity, which you have to work with. So in the end, what are the alternatives? Well, I mean, in my case, I can say that LangChain is probably my first choice. After CrewAI, you have more control. Of course, you don't have all the nice orchestration feature that you see in CrewAI. And in terms of understanding the library, the framework, it's definitely a bit it's not as easy as CrewAI, I would say. And also some other alternatives. I've seen pros and cons. In general, every time I have to go with an orchestrated application, every time I have to orchestrate agents, I prefer to go with CrewAI and maybe use some LangChain tools on the top. But it's a personal choice, and I think it really depends on what you're doing. But I see that each framework has pros and cons. In general, I prefer to go with CrewAI as a first choice because it's easy to use, and then move to something maybe more complicated if I really have to. Apart from this, I hope you enjoyed my presentation, and I would like to thank you all.